LKW 2, bitte warten. LKW 1 wird gerade entladen.
Manifest confirms 4.8 tons. Check the moisture levels here. Within tolerance. I've logged the visual inspection. Good. Finalizing the intake. Moisture content is acceptable at 6 to 5%.
Good. The pH level is stable. Let's log it. Keep an eye on the flow rate. We're getting too many contaminants in this batch.
The sensor reading on line 3 is spiking.
Adjusting the compressed air timing now.
Keep an eye on the magnetic drum temperature. We are running near capacity.
Understood. The sensor readings look stable for now.
This substrate is perfect. We are clear for the next stage. Okay, I will send it through now.
The flow rate seems optimized at this speed.
Agreed, the shredders are handling the load perfectly. The intake flow is slightly high on the south line.
I see it. Adjusting the feed rate now.
Moisture levels are stable at 15%.
Good, the particle size looks consistent. I'm logging the results.
How's the consistency looking over there?
It's uniform. Right on specification.
Look at the fluctuation on screen 3. The nitrates are dropping too fast. Confirmed. Adjusting the feed rate now via the tablet. The substrate temperature is stable at 35 degrees. Good. Let's increase the flow rate by 10%.
That looks correct. The nutrient balance is stable now.
According to the tablet, this section is running slightly dry. I see it. We'll adjust the moisture input immediately. The humidity levels are stable at 85%. Good. Log the data on the tablet. The viability index on cluster 7 is fluctuating.
I see the spike on the thermal map. Let's adjust the humidity immediately.
The temperature is holding steady at 28 degrees.
And the humidity levels are optimal for the current growth stage. Let's maintain these parameters. The first wave is emerging right on schedule.
I am logging the initial data now. The count looks promising.
The data confirms optimal viability. We can proceed with the transfer.
The flow rate seems stable.
Good, let's maintain that for the next batch.
Ensure the flow rate is steady.
Looks good from here. Biomass density is optimal.
Look at the consumption rate here.
Yes, the growth cycle is accelerating faster than projected. The growth rate seems consistent with the optimized feed.
Yes, the tablet is showing a 15% increase from the baseline.
The growth rate on this tray looks promising.
Agreed. The data aligns with the projection.
The automated system is maintaining the precise ratio.
Yes, the substrate dispersal looks optimal on this line.
The average size is slightly below target for this group.
Let's review the feeding parameters from yesterday.
The biomass yield is exceeding projections by 20%. and the lipid content remains high.
The density here is excellent.
Yeah.
Agreed. The substrate conversion rate looks optimal on the tablet.
The growth rate is exceptional this cycle. The moisture content is stable. Yes, they look ready for harvest tomorrow. According to the tablet, the moisture levels are optimal.
Yeah.
Excellent. Let's maintain this setting for the next shift. The separation rate is optimal at this frequency. Agreed. The yield is significantly cleaner. The separation rate is holding steady at 98%.
Confirmed. The residue is clear. We can maintain the current flow.
Keep the flow steady at this rate. The quality is excellent.
Roger that.
The larvae after harvest meet the quality standards. Record the data.
Yes, calibrating the final count now.
We need to monitor the flow rate closely during the transfer to the washing station.
Agreed. The automated system seems to be handling the volume well.
We are maintaining the target cleanliness levels.
Yes, the primary wash cycle is operating at peak efficiency.
The pressure looks good here. Keep monitoring the organic residue levels.
Will do. The system is running smoothly.
The morphology on this sample looks consistent with the standard. No signs of contamination.
Agreed. Logging as compliant.
The UV levels are stable at 250 nanometers. Good. Maintain the flow rate and monitor the larval activity in chamber 3.
The flow rate looks optimal for this batch.
Agreed. The thermal readings are stabilizing right on target.
The larvae are reaching the optimal temperature in the first chamber. Good. Let's monitor the pressure release valve closely this time.
Reviewing the thermal data, we have a significant spike in reactor 4.
Acknowledged. Increasing coolant flow to maintain optimal larva treatment temperature.
Ensure the flow rate is steady as it enters the pre-dryer. Looks stable. The moisture content is within tolerance. The reading on screen indicates a slight anomaly in the drying cycle. I'll adjust the dial now. Let's monitor it for the next 5 minutes.
The humidity levels are stabilizing right on target.
Good. I'll make a note of the current flow rate.
We're seeing a 2% deviation in the drying cycle data.
I'll recalibrate the sensor on tunnel 4.
The color and texture are consistent with the specification.
Good. I'll seal this batch for production.
The input optimization is slightly low here.
Yes, calibrating the feed rate now. It should stabilize before the next batch.
Check the flow rate on line 3.
Confirmed. We are maintaining optimal efficiency. The particle size looks consistent. We are within the specified range.
Good, I'll log the batch data now.
The vibration level is stable at 90 Hz.
Good. The flow rate looks consistent.
The transfer rate seems slightly off on line 3. Adjust the parameters here.
Already on it, the weight consistency is stabilizing now.
Are the traceability codes registering correctly? Yes, all data points match the manufacturing date.
We're hitting the target throughput for the fly protein bags.
Yes, the optimization paid off. We'll finalize the report this afternoon.
The current batch shows a 20% increase in protein yield.
Excellent. We can move this directly to export.
Keep it coming straight, watch your clearance.
Looks aligned.
Bring it down slowly.
The first shipment is away.
Good. The documentation is complete.